Rolling ball sculptures. They take a long time to make, and people who observe them should be able to tell that they are made with precision and care and an enormous amount of great engineering skill. I think I've got all that, and if you watch this video from start to finish, you'll just see my process of how I ended up with this pyramid shape rolling ball sculpture, which is, I think, a piece of absolutely beautiful kinetic art. Let's start at stage 1, design and concept. So, a long time ago I had the idea to make a pyramid shape. What I like are 4 equal sides and a dead square base, filled with copper tracks and lots of dancing balls. All of my tracks are to be kept within the pyramid shape, which means that when the viewer first sees the sculpture, it's a clean, sharp copper object. I thought about using different pyramid height to base ratios. For example, there's the Great Pyramids of Egypt, the Pyramids of Mexico, and of course, the Glastonbury stage. But none of these are actually very tall, and I needed more height to achieve the dancing balls, so unfortunately I had to decide against using any of these as a reference model. Now, all rolling ball sculptures come with a huge project list, and the next 2 questions were how big shall I make this one, and what type of ball lift shall I make? All my work is tabletop size, and I wanted this one to be fairly big, and definitely it had to be square. So to help me picture how big is fairly big, I used some blue tape to mark out my options, and I eventually settled on a base of 500 by 500 with a rough height of 450. Now, it's been 3 years since I've done a helical lift, so I decided it was about time that I tackled another one. My initial plan was to set the lift in the centre of the pyramid, but after a while I wasn't too happy with how much available track space the lift was taking up, so I decided to move it outside the frame as an exception to keeping everything inside, and immediately that idea struck. So now I knew how big the base was and how and where I was going to lift those balls. Now I needed a 500 by 500 base. I contacted a local woodworker who manufactured this beautiful walnut wooden board and thus began the build process. Next, I purchased the ball lift motor and the speed controller that will allow the user to select the speed of the lift and therefore how many balls a minute are achieved. Next up was the balls. I had to choose the size, material and colour. Now, over the years I've used quite a variety of ball materials and sizes. My 2 previous sculptures used 1 inch or 25mm balls. Whilst this size is great, I decided to go for smaller balls on this one, so I went for 18mm balls. The material I chose was phenolic resin, that's the snooker ball and pool ball stuff, which are really stunningly well made and are all the same size, roundness and weight. I wanted a mixture of colour to add a small degree of randomness to the finished design, and I loved the idea that yellow and orange balls would complement the copper tracks and the walnut base, and in my eye spoke towards the exoticness of priceless Egyptian jewellery and a classic Glastonbury sunset. Stage 3, getting going. With the 18mm balls, I needed to space the tracks at around 13mm, so I made a little spacer gauge. As always, I'm making my track rails from 2mm copper wire, and the track spacers are 1.6mm, and all track supports along the way are going to be 2mm because that's just stronger. And it wasn't long before I'd got the hang of this new track width. Then came a serious case of chicken and egg. I wanted to mount the motor under the board, but I didn't know the position to put it until I designed the lift, and I couldn't design the lift without the pyramid being made, and I couldn't make the pyramid on the top surface before the motor was mounted underneath. Got it? Right, it was all a bit tricky. So to help understand the lift height, I worked on the ball distribution centre to get things moving forward. Because this pyramid has 4 sides, I wanted to build 4 separate roots down, and I wanted these to be established right at the very top of the pointy bit. There's not a lot of room at the top, so these things had to be very carefully squeezed in as best as possible. By using 3 rocker switches, 4 equal roots can be made. Now, because I didn't have the finished pyramid frame built yet, I knocked up a quick prototype frame and began to experiment with rocker switches. What happened next was absolutely wonderful, as my prototype went so well that it actually worked first time. And the quality of the build was so good that I should be able to transplant it into the final sculpture when the proper frame was ready. So having finally made a start, I felt confident enough to now turn the board upside down and get on with the electrics. Firstly, I needed to design and make some copper base plates to hold the motor and switch in place. After quite a lot of cardboard templates, I finally found the correct design. Then I set to work on the underside of the baseboard to cut, drill and route out channels to fit these plates, along with all the necessary wires, motor and switch. This sculpture is all run on 12 volts DC, so it's super simple. Right, let's clean up this mess, and now you can see both the switch plate and the motor plate all looking nice and shiny. Underneath you can see all the wires are neat and tidy. The electronics for the switch are safely tucked away and secured in place. The motor is also embedded within a little pocket and held in place with various nuts and bolts. Basically, you plug in the power supply, switch on and select a speed. The motor turns accordingly. And then you switch it off when you've had enough. Right, the next stage is the pyramid stage. No, not that one, this one. Now, all good pyramids require good anchoring down. I considered drilling angled holes and bolting through, but instead I took some copper plates and formed them into anchor plates. These were set at 45 degrees in each corner and bolted firmly to the baseboard. My frame was made of super straight 5mm copper tube, and inside each one is an M4 stainless steel threaded rod. These were bolted to the anchor plates, which set everything to the correct angle, and they all met up near the top. I did do a little bit of thinking about fitting some intermediate supports, but I left that decision till later. At this stage I was super happy, as I was ticking off lots of big decisions from the design and build job list. Next, I could fit the pre-made ball distribution centre. Because I'd already spent time making this pre-made sub-assembly, all I had to do was to fit it to the top of the pyramid as high up as possible. Doing this tied all the tops together and now meant that I knew exactly where the top ball had to be delivered, which meant I could now work on the ball lift. Now, a well-engineered helical ball lift is a real thing of beauty, but it is the most critical and difficult element of this entire rolling ball sculpture. Get any part of it wrong and the whole reliability, integrity and success of the sculpture can be compromised. I began by making a dead straight, super strong vertical length of track. Then I wound a copper coil and carefully stretched it out to length. It had to be long enough to reach to the top, and each coil turn needed to be equally spaced, at least 1.5 ball diameters apart. When I first offered it up to the sculpture, I realised just how tall this thing actually is. Quite a worry. The central core is an M3 threaded rod, which screws directly into the motor. Over this I placed a 4mm copper tube. Next up I soldered 15 perfectly spaced support struts. And then came the trickiest part. I needed to solder the long wobbly coil to the struts whilst making sure the coil was perfectly centred to the axis. Once that was done, I couldn't resist a quick fitting to see it turning in position. After that I snipped back the struts, cleaned it all up, and it was time to try a ball. As you can see, nothing is very straight, especially at the top, because nothing up there is secured or aligned. So the next job was to solder the vertical track to the motor plate, and then sort out the top. First up, I made the exit track that takes all the balls from the top of the lift to the top of the pyramid. This sets the vertical track in an upright position. Then I removed the helical lift for a good fettle to finally try and get it all nice and concentric. To set the top of the lift in the right place, I made a bracket and a widget, which keeps everything arranged correctly and provides a small amount of adjustment in both front to back as well as side to side. And by removing the widget from the bracket, I can remove the helical lift for further adjustment, repair and cleaning. Now I've finally had a working ball lift that carries the balls from the base to the top. But of course, it still needs a ball loading system. I first added a copper hoop to act as an internal ball barrier, then I made a short length of loading track and a kind of backstop. When the helical lift is fitted, you can see how the loaded balls queue up to get into the lift, and whenever there's a little gap, they all move forwards to be lifted. At this point, I place the final order for the full set of balls, which means loads more orange, loads more yellow, and ladies and gentlemen, this sculpture's very latest entry, ivory balls. And now it was time to fully stack the ball lift. Oh, and it was all going so very well. Things I'd like to have inside this particular sculpture are wind chimes that the balls hit. I love copper spirals. I love copper bowls where the balls roll in and come out of a little hole in the bottom. And I think I want to do another loop-the-loop. There's also the ball gathering option as well. But I don't know what I'm going to do inside the sculptures when the build process begins. I just generally do all the engineering stuff first and then see what I fancy later on for the arty stuff. So now I'm just going to start at the top, probably buy some things, do a bit of maths, do some dreaming and just see what happens. At this point I ordered some things and decided to make the subframe that I'd mentioned earlier. This was mainly built using the flame soldering, as these 5mm tubes are quite hard to solder to. Here you can see just how many brackets and clamps I used to keep things positioned during the build process. Once the 4 diagonals and 4 horizontals had been added and cleaned, the sculpture looked like this: sharp, pointy, clean and fresh. But it wouldn't get to stay like that for long, because now it was time to add some curves. I made a half loop using my standard method of track building. This was to provide a full height drop from top to bottom. At the top I made a short length of track to deliver the balls to the top of the drop. And at the bottom the track was made to curve to one side to add more of a 3D feel to the drop. By this point I needed to decide what to do with the balls before they all got to the bottom, and by now I'd received these 3 beautiful copper bowls, so now it was definitely time to consider exactly what I was doing and where I was going to put them. I got these bowls from a UK seller on Etsy and they really are rather lush. But you can't have bowls with holes without adding the holes, which is a painfully indelicate process. After a quick test, yep, they're definitely bowls with holes. I played around with some different placements and settled on something like this. Of course, their final resting position would depend on a lot of other things, like what else am I going to fit, but at least now I was able to decide that the track I was currently working on would not be going via a holy bowl. This is a great opportunity to discuss my preferred method of soldering, which is to use a resistance solder iron. I do get lots of questions about this, and I have a couple of videos linked in the description below. Basically, you attach the negative clamp to a piece of copper and position the carbon tip of the iron near to the joint that you want to get warm. Pressing the foot switch completes the electrical circuit, and a whole lot of amps flow through the copper, which very quickly makes it hot. I then apply solder in the normal way, and I don't bother using any solder flux. But each joint does need a simple cleanup using some wire wool. After making a big curvy track, I turned to a new element consisting of an S-bend track, which I placed inside this sausage-like coil. The balls will roll down the inside of the sausage, which technically makes it a sausage roll. Then I made a rough 2D plan of what each track is likely to do and decided that the sausage roll would need 3 entry points, 1 at the end and 2 on the top. The sausage roll provides a nice safe place for the balls to wait, as well as a clever system of joining the down tracks back together. Once fitted, I needed to join the first track to one of the top holes, and now I had a fully connected up system. Now remember the upright section of track that was too flexible? Well, I replaced it with a much stronger version and redid all my testing. Now the lift was more reliable, I could move on to the next track down. It was time to fit a bowl with a hole. So first I made and fitted a nice curved entry track, and then I soon realised that the balls needed a safety ring to prevent the balls from falling out. Underneath is always a bit messy prior to cleaning up. Once fitted with an outshoot, I could test the bowl in situ. And of course, what's better than a holy bowl? 2 holy bowls. And after 2 comes 3. The third one was the larger one. Sometimes I use my flame soldering kit to generate enough heat for soldering the larger items together. Once the third bowl was installed, I now had 2 complete tracks down. The sculpture was looking pretty good, and it was time to design and fit the next tracks in the gaps. Time for a bit of CAD work. That's cardboard, of course. First I marked the exact positions of the things I need to avoid, and then I sketch out the new track centerline. Then I can mark the inner and outer tracks. Once I've bent the copper for those tracks, I can throw in some spacers, and voila, new track that should fit nicely in the gaps. The next stage is a ball gathering stage. So I really want to do a ball gatherer. I've always wanted to do one and planned to do one from the start of the design. Okay, but have you left enough room for a ball gatherer? Well, not really, no. Well, you can't really have one then. Yeah, but I really want one. But there's not much room. I could make it really small and cute. Small and cute? Yeah. Okay then, let's make a small and cute ball gatherer. As you can see, there's not a lot of room for much copper to be added high up. But I started off making a small and cute copper gathering tray with some side supports. Underneath is a copper tube that will form the hinge. Then I made a little loading chute that takes the ball away from the switch, and that needed to be squeezed into an impossible gap. And now the top section of the pyramid is looking pretty lush and complete. Then I added a side rail which is just big enough to hold 3 balls. And the idea is that when the third ball comes, there's enough weight on one side of the tray for it to tip over and release all 3 balls into the next door track. Then I did a bit of testing on a bit of test track to make sure that the balls would tip when the third one arrived. But I discovered a problem. I'd set the little copper tube too far in the middle, so when the balls arrived, there wasn't any displacement to tip the balls out and I was having to force it. So all this felt like a really massive setback. So I decided to make a replacement tray and set the tube more over to one side. However, the first attempt I burnt through everything and it just didn't work, and the second attempt went terribly wrong. Again, I burnt through the copper tube and it just wasn't going well. So I set about doing it for a fourth time. As I've already alluded to, there's hardly any room for this mechanism. The tipping mechanism has 2 stops here and here. The balls need to miss this existing track, and this existing track needs to pass under this loop that I was forced to provide. And the balls on the lower track need to pass underneath the counterweight arm in these 2 places. And the landing track only just has enough room to be squeezed into this gap before turning sharp right to hopefully fit down this little gap. And I need to leave enough height for the balls to drop from this upper ring to this entry track here. So it is extremely tight and I'm super proud to have achieved it. I interrupt this video just to bring you some bad news. Let's go live now to the bad news cam. Now I've accidentally fitted this track with this ring upside down, which puts the ring on top of the track. Therefore, when the ball comes down, it doesn't fall down the ring, unless it's pushed. Obviously that's not suitable, so I either need to move that ring underneath or replace both these tracks with a new track and a new ring. Thank you for watching the bad news cam. Now, back to the build. I soon had the ring fixed, and then I added 2 new side barriers to help the balls fall reliably onto the tracks. All that was left to do now was to make the catching track and then join all the bits at the top with all the bits at the bottom, and it would be done. And that completed all the tracks to be joined up to the sausage roll. I'd managed to include some long sweeping curves, a vertical spiral, a side winding snake and a bumpy track. Looking at the sculpture from afar, I decided that the overall volumetric balance was lacking a little bit in the lower half, so adding some kind of exoskeleton would improve that, as well as helping to clearly define the sharp outer pyramid shape. Now I must admit that having a copper.gravity logo embedded into the design is quite a new thing for me. RBS7 had one, and so at this point it occurred to me that RBS8 would also benefit by having one. So I made a copper.gravity logo. I twisted it into some nice curves and fitted it low down on one of the four sides. Then I played around with some ideas using scraps of copper to see what would look good on each of the sides. It's quite hard to film copper tubes in front of copper wire, so I've placed some pink lines on top to help you see what I was thinking. But in reality, once I'd got going on adding some extra copper, I ended up making something completely different and better than my original idea. For me, it's really important to make sure that all the extra copper wires are kept dead in line with the sides of the pyramid. The second side I did ended up getting some concentric wire circles. I was inspired by a stained glass design that I'd seen. Right, I think it's now time to reveal the finished product. Thank you so much for watching. A like and a subscribe would really help my channel grow. So, finally, please enjoy Stage 20, the result. I really hope you've enjoyed watching this start to finish rolling ball sculpture RBS number 8 and agree that I've kind of met my design criteria. I've made a pyramid that looks solid copper, but it's got all these dancing balls on the inside. There's lots of motion going on, it's reliable, it looks really good. It's a strong looking piece. One thing I didn't mention is I added the turntable to the bottom, so that was kind of my a little bit of tooling that I was using just to help me manufacture the thing. And about halfway through I had a great suggestion to add the bearing to the base, so that's what I've done. Didn't show that. I hope you've enjoyed this long format video just as much as I've enjoyed making it. It's been 8 months since I started this process. Please subscribe so that you can see me build the next one. I don't know what it's going to be. I don't know when it's going to be. So hit the notification bell. Feel free to comment. I do really appreciate all the comments I get on my channel. I like to reply to every single one of them. You can also check out my website, copper.gravity.com, where you'll find all my previous work listed in a nice order. It's all looking really good. And if you do contact me on my email, the address is below, then I will get back to you. A lot of people want to start this hobby and have a go at home, and I'm more than welcome to give you a few emails just to set you on the way. A lot of people ask about my soldering and exactly what I do with the resistance iron, so yeah, check out that video because yeah, it's got a few tips and tricks in it. Wow, okay, that's it. That's the end of the show, the end of the episode, the end of this sculpture. So, see you on the next one. Bye!